Hello and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating work in text-to-speech synthesis. We'll be looking at a paper titled IndexTTS, an industrial-level, controllable, and efficient zero-shot text-to-speech system. Basically, the researchers introduce a new TTS system, IndexTTS, that builds on existing models like XTTS, but adds some cool improvements. They specifically focused on making pronunciation controllable, especially for Chinese, and enhancing zero-shot voice cloning capabilities, making it more stable and natural sounding compared to previous systems. So Figure 1 gives us a nice overview of the IndexTTS architecture itself. You can see it takes text and some prompt speech as inputs. The text goes through a text tokenizer, while the prompt speech feeds into a perceiver conditioner to get speaker characteristics. Both of these then go into the main text-speech language model, which predicts acoustic tokens. Finally, a big VGAN2 decoder, also using speaker info derived from the prompt speech, converts these tokens into the final audio waveform. It kind of shows how all the pieces fit together for the synthesis. Okay, so speaking of those improvements, especially the pronunciation control for Chinese, Table 2 shows some interesting results on that front. They tested on 2,500 sentences containing polyphonic characters, characters with multiple pronunciations, without any specific guidance, just using the characters. The system made errors in about 465 sentences. That's nearly 19%. But when they provided the correct pinyin alongside the character, row A2 shows they corrected 437 of those errors, which is a 94% correction rate. So this really highlights how effective that hybrid character pinyin input method is for controlling pronunciation. Beyond just accuracy, efficiency is also a big deal for these systems, especially for industrial use. Table 5 here gives us a look at that, comparing IndexTTS to other models like XTTS and Cozy Voice 2 in terms of GPU utilization and how long it took to run a test set. You can see IndexTTS took 397 seconds, which is pretty competitive, faster than XTTS, for example. But what really stands out is the GPU utilization. IndexTTS used only about 28.5%, which is way lower than most of the others. This suggests it's quite efficient with resources, while still being relatively fast. Beyond efficiency, how does IndexTTS actually perform in terms of, how good the speech sounds and how accurate it is? Table 3 gives us some objective measures for that. It shows the word error rate, or WER. Basically, how many words the synthesized speech got wrong compared to the original text, and speaker similarity, or SS. How closely the synthesized voice matches the prompt speaker. Lower WER is better, higher SS is better. You can see across different test sets, both Chinese and English, IndexTTS consistently gets lower error rates, like an average WER of 3.7% compared to 6.0 for XTTS, and higher speaker similarity, 0.776 versus 0.663 for XTTS. This means it's not just efficient, but also more accurate and better at cloning voices. Okay, so those objective numbers in Table 3 show IndexTTS is more accurate and clones speakers better. But how does it actually sound to people? That's where Table 4 comes in. It shows subjective mean opinion scores, or MOS, for the zero-shot cloned voices. Basically, people listened and rated the synthesized speech on things like prosody. The rhythm and intonation, timbre, how much it sounds like the original speaker, and overall quality. Higher scores are better here, and IndexTTS leads the pack with an average MOS of 4.01, significantly better than XTTS at 3.11. It particularly shines in timbre similarity with a score of 4.20, and overall quality at 4.05. So yeah, people agree it sounds more natural and closer to the target voice. So IndexTTS isn't just efficient and accurate on paper, it actually sounds better to people too. It really seems to strike a great balance between performance, like that high-quality voice cloning, and practical efficiency using less GPU. This kind of progress is super important for making advanced text-to-speech usable in real-world applications, not just in the lab. Well, that's all the time we have for today on the AI Research Roundup. Thanks for tuning in. I'm your host, Alex.